I'm here to represent Group 12 for CS263 final project idea presentation. And the project idea here is on-device machine translation with real-time elaboration and Q&A. Let me start with motivation and problem description. So I would like to cover three components here. The first component is language barrier. So language barrier is nothing but the inability or hindrance between two individuals to communicate with each other in the same language. The second one is correctness and latency. Here, let's say we have Google Translate app, and there's no guarantee that it will always produce the correct results. And the latency is a huge factor in Google Translate, because it has to convert the given text into a target text by calling a remote server. So we address the latency issue by doing on-device machine learning. This is something that I'll discuss as we move forward. And the third component is context-based elaboration and Q&A. Let's say you scan a text, which is a question. We just don't translate that question into a target language, but also address the question by giving the answer to that question. So for background related works, these are the two components that I would like to talk about. For the first model type is statistical machine translation, which basically uses statistical methods to do the translation. The second one is neural machine translation, which uses neural networks for translation. The third one is transformer models, which uses self-attention to enhance the neural machine translation. The fourth one is multilingual machine translation, which basically has only had one translation model that converts a given language into any target language. And the fifth one is reinforcement learning with human feedback, which basically uses reward-based learning for machine translation. The sixth one is low-resource machine translation, which basically uses unsupervised learning for converting it to a target language. So these are the list of apps that does machine translation right now, which are out there in the market. The popular one is Google Translate and Microsoft Translator. So these are all the research papers that we grazed over before creating this project. You can pause this video in order to get a more sense of the research papers that we went through. So now let me talk about the approach. For the approach, this has 5 components. The first one is dataset. So here we are using tatobo.org large dataset, which basically has the translation set parallel data that converts sentence by sentence translation from a given target input language to a given language to a target language. The second is the different models that we experiment and compare the results for. So here we are using RNNs and GRU with attention and transformer models. The third one is on-device port. So we are going to build these models and port it into a Android device. And so we are going to convert the TensorFlow models that we're building in the previous step. This is step 2. We're going to convert it into TensorFlow Lite models that can be ported onto an embedded system or a mobile device. And the fourth one is text recognition. It's phone camera, which basically recognizes the text. So we're using MLKit on Android to basically recognize text. And once the text is recognized, we're going to convert that text into a target language text, and we're going to answer the Q&A or elaborate on the scan text. And that is the fifth component to it. We are going to use GPT-3 for elaboration and Q&A. So here is the architecture diagram, or like a flow diagram for the project that we're going to build. So notice that there is towards the leftmost, we have a text which says how to make an omelette. So we are doing all the processing on device on an Android device. So we have text recognition system, which basically recognizes this text, and we have sentence translation system that basically translate this text to a target language text. And notice that the sentence translation model is something which is custom built by us, and we are going to port it onto on-device as an on-device machine learning model. Then once we convert it into a target language, we're going to pass it through an elaboration and Q&A model by using GPT-3 or any similar models. And all of this happens on device. It's also worth mentioning that the elaboration and QA happens to be a remote call, but the sentence translation happens on device by using on-device TensorFlow Lite models. So for results and future plans, we are going to talk just about the preliminary results, just not the final results, and is subjected to improvement as we implement the project. So here we have implemented all three models, and to get an idea of the kind of performance or the accuracy that we get. So here we are going to translate English to Spanish, and keep in mind that this is trained in different epochs for each and every model. So the accuracy might change. For example, you can notice that the transformer has lesser accuracy than GRU plus attention, so ideally transformers usually perform better. But this is something that which we will follow up as we implement the project. And the future plans, which contains ideas that will be done as a part of this project and beyond the scope of this project as well. The first future plan is using different metrics for model evaluation, which includes precision, recall, F1 score. And the second one is improving existing models in terms of architecture and reducing the execution time. And the third one is incorporating chain of thought prompting, chain of thought question answering tasks by using GPT if possible. The fourth one is studying the word alignment. The fifth one is fine-tuning GPTs with custom dataset if possible. And sixth one is prompt suggestions. Yeah, so that concludes the project presentation idea for our final presentation for CS263. Thank you.